Hello everyone, welcome back to another video. Today we want to clarify what a conjugate form of a term is. So this idea, I see this idea very often because it's very important. You should see a lot of ideas where you, for example, have to calculate the lemmas. So this is like how a certain function behaves in a certain area, for example. You need those ideas. So let's have a look. For the conjugate form is defined as a plus or minus the square of b. Then the conjugate is a minus plus b. If you say those are equal, be careful of this. So what you're going to do is turn around like this, this expression, I would say. So if it's plus, so it's a plus square of b, you would say a minus b is the conjugate form, and if it's a minus, you say it's a plus, yeah. So let's have a look at the example. So if we have any form, for example 1 divided by a plus minus the square of b, the conjugate form would be a minus plus square of b. Why is this true? Because this term here equals to 1, and therefore this still stays true. The result of this is quite easy. Since we multiply those expressions, what we get is a minus plus b, so square of b, a squared minus b. You see, what we did here is we got away this square out, So let's see how we can do this with a simple term like square root of 3 plus 2. Let's try to solve this. So we know we don't want to have this here, so what we're going to do is we are going to just multiply this. Be careful of this. We see this as a plus, so this has to be a minus. So we just multiply this with square of 3 minus 2 divided by square of 3 minus 2. If we now would multiply this gives us minus 3 minus 2, and this would just give us 3 minus 4, which is equal, in this case, to, be careful, this is minus 1, therefore minus 1 here. Therefore, minus square root of 3 minus 2. Let's have a look at another example. If we, for example, say we have a product of this thing here, maybe because you don't understand this, we know this is nothing else than this, right? Now try to understand why this expression, what we did here, so we said this is nothing else than 3 minus 4, why this is true. This is true because this is nothing else than a binomial formula. You remember, the form of a binomial formula is a plus b times a minus b equals to a squared minus b squared. Since we now have here, let's bring it in the form a plus b. If we, for example, say we've got a plus square of b times a minus b, we know the product will be a squared, be careful, not b squared, but instead b, because here we have the square, and we know a square root times a square root equals to square root a, which is equal to a. So let's try to have a bit more examples. So for example, let's take 3 divided by square root of 7, square root of 7 is correct, I'm sorry. And now try to simplify this. Pause the video. So this is nothing else than 3 divided by square 7 plus 4 times square of 7 minus 4 divided by square of 7 minus 4. Now, let's try to multiply this with each other. So we know here this will give us 3 times square root of 7 minus 4 divided by 7 plus 4 times square root of 7 minus 4. So now try to simplify this. We know this here is nothing else than 3 times square root of 7 minus 14. Now let's, because I see something, let's try to just leave it there. Try to get here the idea. So this here is 7 minus 16. And this here is 3 times square root 7 of minus 4. This will give us, so 7 minus 16 is nothing else than minus 9. Therefore, we get minus 9 divided by 3 times 7, square root of 7 minus 4. And now what you can see, we just can say we're taking this away, and therefore we still, because we have a multiplication, no addition, so this is valid. So we just can say this is nothing else than 7 minus 4 divided by minus 3. And this is nothing else than square root of 7 minus 4 divided by minus 3. And because of the rules of like this is nothing else than minus 7/3 plus 4/3. So let's try to get the same idea at another example. Let's say we have something like 1 divided by square root of x minus 3 equals to 2. The only thing what we're now going to do is we want to multiply this. So we're just going to say this is nothing else than minus 3 times x minus 3, goes like this, equals to, we have to do the same thing on the other side, minus 3. Since this and this just disappears, we get 1 equals 2. 2 times x, square root of x, minus 6. No, we just can do here, since this is, since we want to have the x on one side, let's just say here this is plus 6, so we could say this is 7, 2x, and now we just can divide by 2, we get 7/2 equals 2 square x. We could just like try to get rid of the root, and then we would get squared equals to x, which is nothing else than 94 equals to x. Let's see why we need this. So if we want to find how a function behaves if it's going in the direction of 4, so x to 4, we need to plug in our 4. The problem here is if we plug in x equals to 4, this here would work, but oh no, x minus 4 equals to 0, and we cannot divide by 0. The proof for this, you should know if you watch another video series, is pretty easy, because if we say something, so there's an a, and a equals to x divided by 0, this would mean a times 0 equal to x, and there is no x which fulfill this. So let's try to get something like this. You can try to solve this for yourself. As I said, the goal is that we don't have something like this in, so because we cannot divide by 0, so we want to try to eliminate this. You can pause the video, but I'm going to start right now. So the only thing what we're going to do here is x minus 2 divided by x minus 4, and now we're going to take the conjugate form, which is square root of x plus 2 divided by x plus 2. If we're now going to simplify this, we get here, remember, now we're just doing the same thing like before, x squared minus 4 divided by x minus 4 times square root of x plus 2. I'm sorry, I did a mistake. I just wondered. So, of course, this has to be because we're squaring this. So, we're squaring the root of x, so x squared gives us x. So, this is x minus 4. So, we know this equals, if we know, just plug this away, we get nothing else than 1 over square root of x plus 2, and now we can plug in 4, and we get 4 plus 2, which is equal to 2 plus 2, which is equal to 1/4. So if we have like any function, if we have the function which looks like this, we will see that our function to f is going to near 1/4. So to just show you that it's true, oh I'm sorry, that shouldn't be here. If we now would zoom to the 4, what we can see, this is true. So we do actually see that it's getting to 1/4. But if we just wouldn't see this term, we couldn't say this. So this is how you're going to, think with the conjugate form. What is important is just search for this term, and then just the conjugate form is going to be reversed term of that. See you soon.